You sit down in the lecture hall and the barrage begins immediately. The professor starts talking, the slides are clicking past, and there's a handout on your desk demanding all your attention. It's a torrential downpour of information. Your brain hits a wall of cognitive overload trying to process the audio, visuals, and text simultaneously. So you do what almost everyone does to survive. You put your head down and try to write every single word. You treat your notebook like a tape recorder, trying to capture a permanent, flawless record of the hour. This is known as the transcriptionist trap. When you focus entirely on getting the words onto the page, your brain bypasses the actual meaning of those words. You're acting as a human printer, not a student. If you treat note-taking as a passive bucket to catch data, you will stare at those notes weeks later during exam review and realize you don't actually understand any of it. Instead, effective notes require an active filter. To build that active filter, you have to match the visual structure of your notes on the page to the underlying cognitive structure of the material you're hearing. A history lecture on the French Revolution and a biology lecture on cell division present information with entirely different logic, yet many of us use the same default method for every class we attend. Let's look at 3 structural tools: the linear note, the mind map, and the Venn diagram. We will measure each against 3 criteria: what they're best used for, their cognitive load, and the specific risk of using them in the wrong context. Understanding the structural strengths and weaknesses of these 3 specific formats will allow you to strategically deploy them based on specific lecture cues. Let's start with the most common tool, the linear note. This involves organizing information sequentially using headings, bullet points, noun phrases, and abbreviations. Look at this page of notes on leadership styles. You can see how the text is sequentially structured into organized, indented facts. This format excels at capturing chronologies, step-by-step processes, and high-density factual logging. When a lecturer is firing off dates or sequential events, the linear note keeps up. Returning to our matrix, we can see the linear method is best for timelines and processes. Because it's so straightforward, the cognitive load required to write this way is very low. But that low cognitive load brings a major trade-off. The lack of friction makes it incredibly easy to list facts without ever connecting them, evaluating them, or understanding their significance to the broader topic. While linear notes capture raw data efficiently, they pose the highest risk of passive capture. You can fill an entire page and miss the conceptual relationships entirely. That brings us to the mind map. Here, you place a core concept directly in the center of the page and draw branching lines outward to connect definitions, explanations, and specific examples. In this diagram, we map the concept of biomimetics. We start with the central node. As the lecturer explains, we expand the branches to show the hierarchy, mapping the idea to its definition, the scientific study of design in nature, and its application in man-made objects. This visual format forces your brain into active categorization. You have to decide how a new piece of information relates to what you already wrote down before you can draw the connecting line. Looking at the matrix, the mind map is best for hierarchies and definitions. But because you are constantly making spatial decisions, the cognitive load is high. That high spatial planning introduces a specific risk. If the lecturer suddenly lists 20 sequential facts or goes on a tangent, your page will quickly turn into a messy, structurally broken web. Mind maps trade simple data capture speed for immediate conceptual synthesis. You get a mapped relationship, but you must work harder in the moment to build it. The third tool is the Venn diagram. This relies on overlapping circles used exclusively to actively categorize incoming data by shared and unique traits. This chart compares 2 competing products, the Apple iPod and Microsoft Zune. As you listen, you sort the details. Shared traits, like playing music and video, go into the center overlap. Unique traits, like being technically superior, get sorted under the specific product. This method generates an immediate comparative analysis. By the end of the lecture, you have a sorted argument that is practically ready to be written directly into an academic essay. But the limitation is severe. It is a completely useless input method for linear timelines, standard definitions, or single-subject deep dives. Let's complete the matrix. The Venn diagram is best for comparisons, but the risk is that it is highly specialized and useless for standard timelines. The Venn diagram offers the highest return on investment for later exam prep, but you can only use it if the lecture's structure permits it. Swapping tools dynamically based on the lecturer's signposting language removes the guesswork from the start of class. Lecturers often explicitly announce their structural intent right up front, giving you a roadmap for the tools you'll need. You can map these audio cues directly to your note-taking formats using a simple decision tree. If you hear cues like, "Let me explain why," or "Here is a definition," branch to a mind map format. When the lecturer says "compared to," or "on the other hand," shift into a Venn diagram. And if you hear phrases like "there are 3 stages," or "first let's look at," return to linear notes. Mastering the transition from passive listener to active student depends on recognizing these auditory triggers. If you are someone who tries to transcribe everything, ending every class with hand cramps and low retention, your habit is working against your comprehension. Force yourself to use mind maps. The friction of having to stop and draw relationships breaks the passive transcription habit and forces you to evaluate what you are hearing. On the flip side, if you are a synthesizer who loves drawing big-picture visuals, you might be dropping critical data points when the lecture speeds up. Selectively deploy linear notes the second a lecturer signals a timeline or a process. This ensures those hard, sequential facts are preserved for your review. Prioritize an active, adaptable map of understanding over a perfect transcript. Walk out of the lecture hall with a strategy that matches the material.